Okay, so for the first one here, find all the roots or the x-intercepts for f of x equals x to the third minus 2x squared minus 4x plus 8. Remember, our first step is to set it equal to 0. And then, of course, our second step, we look for greatest common factors. Well, there are no common factors here. There's no variable that goes in every term, and there isn't a number that's divisible into each coefficient. So the next step, if it were two terms, we would look for special products, that difference of perfect squares, sum or difference of perfect cubes. It's not two terms. If there were three terms, we would do that reverse multiplication to factor it. This one is four terms. When it's four terms, we look at grouping. And grouping just means I'm going to try to take the first two terms and the last two terms. Now I'm going to make sure I include that negative in there as part of it. So in these first two terms, x to the third and negative 2x squared, my common factor there would be x squared. So I divide out the x squared from those terms. I'll give myself a little more room here. So I divide out that x squared. What's left is x minus 2. Now the next one over here, looking for there's a common factor of 4, but this is a positive x here, so I want to make sure that's a positive x as the first part over here. So to make that positive, I'm going to factor out a negative 4. So it'll be minus 4. When I divide out that negative 4, negative 4x divided by negative 4 is just x. Positive 8 divided by negative 4 is negative 2. And we've accomplished the goal we want. We wanted to make sure we got the same expression inside the parentheses for both groupings. So now we go back and we can make things, well, we actually do a second greatest common factor here. What I'm going to do is I'm going to pull out the x minus 2. And what's left there is x squared minus 4. Now we're not done because this can still be factored. So the x minus 2 is there. X squared minus 4 is x plus 2, x minus 2. So we go to solve these, we're going to find that two of them give us the same equation. X minus 2 equals 0. Solving that by adding 2 gives us x equals 2. This one, of course, gives us x plus 2 equals 0. Solving that for x, you subtract 2, x equals negative 2. Now there's something going on here that I want to talk about more, and that's called multiplicity of zeros. That x minus 2 appears as a factor more than once in this expression. So what that means is when we're going to graph that, let's actually punch that into the graph here. I'm taking the shortcut and using the graphing calculator. So use x to the power of 3 minus 2x squared. Oops, try that again. X to the power of 3, I got an arrow out of the power. Minus 2x squared minus 4x plus 8. So if we graph this, we'll do a standard zoom. What you see there is that graph comes down and hits the axis. Let me sketch it out for us here. So we have a 0 or a root here at negative 2 and one at positive 2. Our graph did one of those. Whenever we have a root that is repeated an even number of times, like this was repeated twice, That's exactly what happens is the graph comes down and touches the axis at that point, and then it takes off in the other direction. So we refer to that as an even multiplicity. And it'll either come from the top like that, touch and go down, or go up. So it either does that, or it comes from the bottom and touches and goes back down. Now that same root could be repeated 4 times and it could do the same thing. It would be just a much narrower, come down to a tighter point instead of that gentle curve. If it's an odd multiplicity, it does a similar thing. It comes up to the axis and actually becomes, this is right here is what we refer to as being tangent. The axis is tangent to it because it touches it. It actually has a slope equal to the curve. So the slope of that curve is 0 where it touches that axis. Well, in an odd multiplicity, it does a similar thing, whether it's coming from above or below. For my example here, I'm just going to come from below. It touches the axis, and it becomes tangent to it. So it has 0 slope there, but then it turns and goes the other direction. Or it could have done the same from the top. It could have come down from the top, turned and become tangent to the axis, and then turns and goes through it. So that'd be if that same root was repeated 3 or 5 times. While we're here, let's review some of the things we learned at the end of class last week. This is a polynomial function. Remember, there is the a term that multiplies the largest power, the largest degree component of that, which is the x to the third. Well, there's no number there, so that's saying a equals 1. So that term is 1. Remember, if that is positive, and our power here is odd, that means on the left side of the graph, it shoots down to negative infinity. And on the right side of the graph, it shoots up to positive infinity. If this were positive, well, it is positive. If this were positive and that power were even, it goes to positive infinity on both sides. Remember those little things. Those are shortcuts we're going to use today for graphing polynomial functions. If that first coefficient is negative, it just flips everything over. Let's move on to number 2 here. Put f of x equals negative x squared plus 4x plus 12 into our graphing form. Y equals a times x minus h squared plus k form. Also want you to list the vertices and the roots, or the vertex and the roots. Well, the vertex we'll find once we put it in this form. The roots might be easier to find before we do that. So let's find the roots. So remember, once again, you put 0 in for y, or f of x, and you solve. Now the coefficient on the x squared is negative, so the first thing I'm going to do is I am going to take out a common factor of negative 1. That way that's a positive x squared, and it's just more comfortable for me to factor it when it's a positive x squared. So now that x squared minus 4x minus 12 is factorable. That is x minus 6 and x plus 2. So giving us factors, I'll put them up here. Either x minus 6 is 0 or x plus 2 equals 0. Now I'm just going to assume you can solve those. You can add 6 and subtract 2 to get our roots of x equals 6 or x equals negative 2. So those are the roots of that equation. If I wanted to be technical, I could write them out as 6, 0, and -2, 0 as my roots. Okay, let's put it in graphing form now so that we can find that vertex. So I'm going to write it as y equals -x² plus 4x plus 12. And the first thing I'm going to do up above, when I factored it, I just factored out a -1. What I'm going to do here is I'm going to multiply both sides by -1 just to get rid of that negative. So I've got a -1y equals x² minus 4x minus 12. Now I want to get rid of that 12, that minus 12. I'm going to add 12 to both sides. Well, on the left side, that's just -1y plus 12. On the right side, I've got x² minus 4x. Since the coefficient on the x² is 1, which is what we'd prefer it to be, we can now find what this needs to be. We're just going to take this middle term, the -4, we're going to divide it by 2, and then we're going to square it. So -4 divided by 2 is -2. -2 squared is 4. So this needs to be a 4 here. So I'm going to add 4 to make that happen, which means I have to add 4 over here. So I've got -1y plus 16 equals x² minus 4x plus 4. So remember, the whole purpose of doing this was to create that perfect square trinomial, which of course is the square of a binomial. So our next step is to convert this perfect square trinomial into a binomial squared. That is just x minus 2 squared. We didn't do anything to the left side at this point. Now from the left side, we need to do two things. I am going to first go a little backwards. I am going to divide out the -1 or multiply by -1. Probably the simpler way of thinking it if you prefer. So now that's a positive 1y or just y. That's going to be a minus 16 now, equals -1 times x minus 2 squared. And now, final step, I will add the 16 to get y by itself. So in graphing form, I have y equals -1 times x minus 2 squared plus 16. And of course, you would replace that y with f of x. The vertex is pretty simple to read off of here. What is it? What was that? Perfect. +2, +16. Now there's one other piece of information in here that I didn't ask for, and that was, does this open up or down? Perfect. -1 means it opens down. So that's telling us that on our graph, we had roots at -2, +6. We have a vertex at 216, and we open down. So it looks something like that. If we were to ask for it, what would the equation of the axis of symmetry be here? X equals 2, perfect. There's two ways to find it. One is it is just the X coordinate of our vertex. The other way, if we didn't have the vertex, is we could take the two roots, -2 and +6, and we could average them together. -2 plus 6 is 4, divided by 2 is 2. So both of them give us X equals 2. Okay, were there any questions off the homework from last Wednesday? I realize we're starting to get into the stuff that's a little bit more confusing. Noah, how about you? Everything looking good? Perfect. Okay, well then today we're going to move on. We're going to take this next step, continuing with these polynomial functions. Working with these big polynomial functions, one of the things we need to be able to do is to divide polynomials. So when we've done some division with polynomials a little bit, a polynomial divided by a monomial that looks something like this. So 36x to the fourth minus 18x to the third plus 45x squared divided by 9x. And to do that, we just went term by term. 36x to the fourth divided by 9x. 36 divided by 9 is 4. X to the fourth divided by x was x to the third. The next term, -18x to the third divided by 9x. We divided the counts. -18 divided by 9 is -2. X to the third divided by x is x squared. And then the final term, 45x squared divided by 9x. 45 divided by 9 is +5. X squared divided by x is x. Well, today we want to look at what happens if we divide that polynomial by a monomial. So we might have a polynomial like that divided by x minus 1. Well, this one's a rather easy division. If you notice, when you look at this trinomial here, you might recognize that that's factorable as x plus 2 times x minus 1. And if that's the case and we're dividing it by x minus 1, well, you can just cancel out the x minus 1 factor to get x plus 2 as our resultant of that division. But not all of our polynomials are going to be easily factorable like that. And if there's a remainder, factoring isn't going to work. And of course, we're going to look at some polynomials that are a little bit higher degree where factoring might not be easy to do anyway. So how would I have approached that? If I had my x squared plus x minus 2, then I'm going to divide by x minus 1. So we are going to start with x. We're going to do the leading terms. X goes into x squared. That's just x. X times x is x squared. X times -1 is -x. And now we have to subtract. X squared minus x squared, well, that cancels out. Here's the tougher one, x minus a -x. Well, that's 1 minus a -1, that's 2x. Then I bring down that next term, minus 2. X going into 2x, it goes in there twice. +2, so I put a +2 up there. 2 times x is 2x. 2 times -1 is -2. We subtract, that's zeros all the way along, everything cancels out. So that's it, x plus 2. That's the exact same thing we got when we divided, so we did the factoring and canceling. Let's look at one that might not be quite so pleasant to factor out. So we're going to do 6x to the third plus 17x squared plus 27x plus 20 divided by 3x plus 4. Now again, we will start by only looking at the leading terms. So we have a leading term here of 3x in our divisor and 6x to the third in our dividend. Well, 6x to the third divided by 3x, that's 2x squared. So let's multiply that out. 2x squared times 3x, that's 6x to the third. 2x squared times 4 is 8x squared. We go to subtract here, 6x to the third minus 6x to the third. Cancels out, we're good, that's 0. 17x squared minus 8x. 17 minus 8 is 9. X squared will bring down the next term, positive 27x. Again, back to those leading terms, 3x into 9x squared. Well, 9x squared divided by 3x is 3x. Then we multiply it back through. 3x times 3x is 9x squared. 3x times 4 is positive 12x. And we'll subtract. Well, 9x squared minus 9x squared is 0. 27x minus 12x is 15x. And we bring down that next term of a positive 20. Back to the leading digits again, leading coefficients here. 3x goes into 15x. 15x divided by 3x is a positive 5. 5 times 3x is 15x. 5 times 4 is 20. When we subtract there, we end up with 0. Everything cancels out. So that divides out evenly. So 6x to the third plus 17x squared plus 27x plus 20 divided by 3x plus 4 is 2x squared plus 3x plus 5. Why does that help us? Because actually that's the factorization of that. The 6x to the third plus 17x squared plus 27x plus 20 can be written as 3x plus 4 times 2x squared plus 3x plus 5. This, by the way, can't be factored. Remember how to check if that's factorable? We had A, B, and C. If B squared minus 4AC so B squared would be 3 squared. 4 times A is 2, C is 5. So this is 9 minus 40. That's negative. If that comes out to be a negative, it is not factorable. That's that discriminant from quadratic formula. Any questions? I'm going to have you guys try one in your notes. I'm going to have you do 6x to the third plus 7x squared plus 12x minus 5 divided by 3x minus 1. I'll give you a couple minutes to work through that, then we'll go over it. So let's take a look here. So we start out with the leading coefficients here. 6x to the third divided by 3x is 2x squared. Multiplying it out, 2x squared times 3x is 6x to the third. 2x squared times negative 1 is a negative 2x squared. And we'll subtract. So the 6x to the third minus 6x to the third is 0. 7 minus a negative 2 is 9x squared. Bringing down that next term of positive 12x. Leading coefficients again, leading terms, 9x squared divided by 3x is 3x. Multiplying it back through, 3x times 3x is 9x squared. 3x times negative 3 is a negative 3x. Subtracting, 9x minus 9x cancels out. 12 minus a negative 3 is 15x. Bringing down the negative 5. 15x divided by 3x is a positive 5. Multiplying it out, 5 times 3x is 15x. And 5 times negative 1 is negative 5. And everything there, when we subtract, cancels out to 0. So that is it. 6x to the third plus 7x squared plus 12x minus 5 divided by 3x minus 1 is 2x squared plus 3x plus 5. Now your book teaches a shortcut, and the shortcut it uses would not apply to this problem here. It only applies if you're dividing by something of the form x minus c. So that coefficient on x in your divisor has to be 1. So let's do a problem. We're going to do these side by side. 5x squared minus 12x plus 8. Sorry, minus 12x minus 8. Divided by x plus 3. So I do the leading terms again. 5x squared divided by 5, or by x, is just 5x. Multiply it out. 5x times x is 5x squared. 5x times 3 is 15x. And we subtract. Well, 5x squared minus 5x squared cancels out. Negative 12 minus 15 is a negative 27x. Bring down the negative 8x, or the negative 8. And we divide. Negative 27x divided by x is negative 27. Negative 27 times x is negative 27x. Negative 27 times 3 is a negative 81. We subtract here. Negative 27x and negative 27x cancel out. Negative 8 minus a negative 81. Negative 8 minus a negative 81 is negative 8 plus 81, otherwise known as 73. So we have a remainder of 73. The way we typically will write that, rather than listing it as a remainder like that, we'll do it in fraction form. We'll put plus 73 over x plus 3, right as a fraction. The remainder over the divisor. Well, since this is of the form x, x with a coefficient of 1 on it, we can do synthetic division. Synthetic division is a shortcut that goes through, simulates all these steps without all the calculation and subtraction. So what synthetic division does, if we're dividing by x plus 3, we put it in that form of x minus c, x minus a constant. So that would be In that form, this would be x minus a negative 3. That's equivalent to x plus 3. So C here is negative 3. So we're going to take that negative 3. Then we're going to take the coefficients of each term in that polynomial that we're dividing. We had 5, negative 12, and negative 8. And from there, our calculation is pretty simple. I'm going to leave a line here. The first number we just drop down, 5. We do 5 times negative 3 is a negative 15. That goes under the second coefficient. Then we add. That is addition there. Negative 12 plus a negative 15 is a negative 27. Negative 27 times 3 is a negative 81. Once again there, negative 27 times negative 3 is a positive 81. Sorry about that. And then we are adding there. Negative 8 plus 81 is a positive 73. The last digit is our remainder. If it divides out evenly, that'll equal 0. And then we go back through the rest of it and we fill in the appropriate powers of x. This first one is the constant term, the x to the 0 term, or the ones. This would be the x term. So that is 5x minus 27 with a remainder of 73. We'll write that as 73 over our original divisor of x plus 3. Now this synthetic division is quicker. And if you remember the process, yeah, it's simpler. The problem is remembering the process. The biggest mistake people make is they forget to change it. Since we were dividing by x plus 3, a lot of people want to put positive 3 in there, but it's got to be the opposite sign. Personally, I prefer to do the long division. This doesn't seem that tedious to me, and I make a lot less mistakes when I do it this way. Synthetic division for me, for some reason, I always tend to reverse a sign somewhere in it. Let's do another example of that synthetic division. The example I want to do looks like this. 6x to the 5th minus 2x to the 3rd plus 4x squared minus 3x plus 1 divided by x minus 2. Now, before we start dividing with this one, is there anything in that polynomial that looks just a little bit off? It goes from x to the 5th to x to the 3rd, doesn't it? We're missing that x to the 4th term. We must, even if we're doing the long division, we must have that term in it. So we have to rewrite this as 6x to the 5th plus 0x to the 4th minus 2x to the 3rd plus 4x squared minus 3x plus 1. Every power of x has to be accounted for in descending order. If one's missing, we have to put it in there. This is x minus 2, so c equals 2. It's already in x minus form. So if I'm going to do my synthetic division, I have 2, 6, 0, negative 2, 4, negative 3, and 1. We drop the first coefficient, the 6. Then we're going to multiply by a c. 6 times 2 is 12. Now remember, we add 0 plus 12 is 12. Multiply by a c. 12 times 2 is 24. Again, we add. Negative 2 plus 24 is 22. 22 times 2 is 44. And we add. 4 plus 44 is 48. 48 times 2 is 96. Negative 3 plus 96 is 93. 93 times 2 is 186. 1 plus 186 is 187. Remember, this last one is the remainder, so that is saying 187 over our actual divisor of x minus 2. The 93 is our constant term. It's positive. 48 is our x term. Positive. 22 is our x squared term. Positive. 12 is our x to the third term. And 6 is our x to the fourth term. So that's our answer. Even if we were going to do the long division, we needed that 0x to the fourth in there. So it's divided by x minus 2, right? Yep. Now, since we've already divided it out over here, a synthetic division, I'm going to fly through this a little bit. 6x to the fifth divided by x is 6x to the fourth. Multiplying it back out, that's 6x to the fifth minus 12x to the fourth. Now you'll notice this is a positive 12, this is a negative 12, but remember over here, we added instead of subtracting. 0 minus a negative 12 is positive 12x to the fourth. Over here, we did get a positive 12 after that. So bring down the next term, negative 2x to the third. Divide leading terms, 12x to the fourth divided by x. 12x to the third, multiplying it out. That's 12x to the third minus 24x to the, 12x to the fourth minus 24x to the third. X to the fourth cancels out. Negative 2 minus 20, or minus a negative 24 is 22x to the third. Bring down the x to the fourth, or 4x squared. 22x to the third divided by x is 22x squared. Multiply it out. 22x squared times negative 2 is negative 44x squared. So again, we subtract the x to the third, cancels out. 4 minus a negative 44 is 48. You can see the numbers in the synthetic division are still, adding up. They're matching up. Bring down the negative 3x. This becomes 48x. Multiplying it through, that's 48x squared minus 96x. Negative 3 minus negative 96 is 93x. That gives us the 93 here that we multiply through. So we should bring down the negative 1. We multiply through to get 93x plus 186. Of course, we subtract that, we get 187. Should be minus 186. So you can see that's a positive 1, that's why it did come out. So we have that remainder of 187. So you can see the long division gives us exactly the same answer. The synthetic division is a lot shorter and a lot quicker. The key is just making sure you remember the steps correctly. Not trying to deter you from the synthetic division because it does save quite a bit of time. But like I said, I do tend to make way fewer mistakes in the long division. So why is it that we care about dividing polynomials? Well, as we factor, if we can discover a factor of a polynomial, dividing it out gives us a simpler polynomial that we can then continue to try to factor. And one of the things we can do, or one of the tools we can use to try to find those factors, is something called the remainder theorem. What the remainder theorem tells us is, again, if we're using that synthetic division, if we're dividing by something of that form of x minus c, so up above here, c was equal to 2. If I find f of c, so in this case, that would be f of 2. In that function, I'll put the same equation back up here. 6x to the 5th minus 2x to the 3rd plus 4x squared minus 3x plus 1. If I substitute 2 in there for x, so this would be 6 times 2 to the 5th minus 2 times 2 to the 3rd plus 4 times 2 squared minus 3 times 2 plus 1. I'll give you a second to catch up on writing that out. Two to the 5th is 32, so this will be 6 times 32. 2 to the 3rd is 8, so this is minus 2 times 8. Plus 4 times 2 squared is 4, so this will be 4 times 4. That's all our exponents. Now we'll go back and multiply left to right. 6 times 32 is 192. 2 times 8 is 16. 4 times 4 is 16. 3 times 2 is 6. So now I'm just going to go straight across here. 192 minus 16 is 176, plus 16 is 192, minus 6 is 186, plus 1 is 187. F of 2 is 187. Now, if you take a second, that should look familiar. When we divided by x minus 2, remember that's where that c of 2 came from. The remainder was 187. That is our remainder theorem. So when dividing by x minus c, the remainder will equal f of c. Okay, it's time to take a break. It's actually 10:21. Let's take a little bit here. We'll come back at 10:30 and we'll continue from. So one of the consequences of this remainder theorem is if x minus c is a factor of f of x, then the remainder has to equal 0. So f of c would have to equal 0. So what this does is it gives us a quick way to test factors. So if I want to take something like f of x equals x to the third minus 2x squared minus 5x plus 6. And test is x minus 3 a factor. What I'm going to test here, that's of that form x minus c, so c equals 3. So what I'm going to test is this f of 3, does that equal 0? Well, f of 3 is going to be 3 to the third power minus 2 times 3 squared minus 5 times 3 plus 6. 3 to the third power is 9. 3 to the third power is not 9. 3 to the third power is 27. 3 to the third power is 9. Actually, 3 squared is 9. Let me try that again. So 3 to the third power is 27. 3 squared is 9. I make my tongue work right today. So now we've got, do the multiplication. 2 times 9 is 18. 5 times 3 is 15. And now we'll go ahead and we'll add and subtract straight across. 27 minus 18 is 9. Minus 15 is negative 6. Plus 6 equals 0. So that is a factor. X minus 3 is a factor of x to the third minus 2x squared minus 5x plus 6, because f of 3 equals 0. So in your notes, I want you to test for me, is x plus 2 a factor of f of x equals x to the third plus 5x squared plus 7x plus 2. I'll give you a minute to try that, and then we'll go over it. So let's take a peek. C for this one, remember this is x plus 2, so I have to change that to x minus a negative 2. So C is going to equal negative 2. So that's what we're looking for, f of negative 2, which will be negative 2 to the third power plus 5 times negative 2 squared plus 7 times negative 2 plus 2. Negative 2 to the third power is negative 8. Negative 2 squared is 4. Then we'll do our multiplying. So the negative 8 here doesn't change. 5 times 4 is 20. 7 times negative 2 is a negative 14. Then we'll just add and subtract straight across here. Negative 8 plus 20 is 12. Plus negative 14 is negative 2. Plus 2 is 0. So yes, x plus 2 is a factor of x to the third plus 5x squared plus 7x plus 2. So we can test a root quickly to see if it is a factor. How do we know what to try as factors? There's something called the rational root theorem. In a function of the form f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1. All all the way on down to a sub 1 x to the 1 plus a sub 0. The roots will be of the form where p is a factor of a0 and q is a factor of an. All the roots will be of the form of p over q. Well, let's take a look at that. So if I ask you to find all the rational roots for f of x equals x to the third minus 2x squared minus 11x plus 12. Now, generally, we would set that equal to 0. For this polynomial function, an, which is the coefficient of the largest power, is equal to 1. So its only factors, just 1. There's nothing else to split it up into. A0, which is the constant term, is 12. It has factors. Now, normally when we were factoring, we wouldn't count 1 in the number itself. Here we will. So 1, 2, 3, 4, 6, and 12. Those are the factors for 12. Now, the fact that an is 1 makes this a lot simple for us. So our possible factors I just take all these factors of a0, that's our p's. Our q is always 1, so let's just take each of them divided by 1. So our possible factors to test, 1, 2, 3, 4, 6, and 12. To test them, we use that remainder theorem. Let's test 1. F of 1 is going to be 1 to the power of 3 minus 2 times 1 squared minus 11 times 1 plus 12. That's going to be 1 minus 2. I don't know why I put an extra 1 in there. That's just 11 times 1, not 11 times 11. But minus 11 plus 12. 1 minus 2 is negative 1. Minus 11 is negative 12. Plus 12 is 0. 1 is a factor. So that means, 1 is a root, which means a factor is x minus 1. Remember, that means c equals 1. So x minus c would be of the form x minus 1. We could try some of the others. Let's try f of 2. That'd be 2 to the power of 3 minus 2 times 2 squared minus 11 times 2 plus 12. 2 to the third is 8. 2 squared is 4. We multiply out here. 8 minus 22 plus 12. If we add that up, we get negative 10. 2 is not a root, so therefore x minus 2 is not a factor. And we could test all the rest of these in there. The problem is, well, there's a lot of them, for one, and not only do we have to test all of them, but we would have to test their negatives. We would also have to test -1, -2, -3, -4, -6, and -12, because those are possible roots as well. So what I'm going to do is, since we have one root and one factor here, I am going to do my division and see what's left. So I've got the x cubed minus 2 minus 11 plus 12. Let's do this. Let me get this correct. Minus 2x squared minus 11x plus 12. And we're dividing that by x minus 1 was our factor. Well, let's go ahead and do the synthetic division with 1 there. C is 1. So 1, -2, -11, and 12. So we bring down the 1. 1 times 1 is 1. We add, that's -1. 1 times -1 is -1. -11 plus -1 is -12. -1 plus -12 is -12, so that's 0. So we got a remainder of 0. So what this is saying is that it's x squared minus x minus 12. The reason I divided that out is now that this is down to a power of 2, it should be easier to factor. And it is. We can factor that as x minus 4, x plus 3. So the third factor, of course, was x minus 1. So those are the factors of that polynomial. It gets to be a lot more complicated when that leading coefficient is not 1. Oops, let's write it down right here. Let's do 2x cubed minus 5x squared minus 6x plus 4 equals 0. So for the 2, I have 1 or 2. For the 4, I've got 1, 2, or 4. So my combinations, I've got 1 divided by 1, 1 divided by 2, 2 divided by 1, 2 divided by 2 is just 1. I don't have to repeat that. 4 divided by 1 is 4. 4 divided by 2, I already have a 2, so I don't have to repeat that. So those are my possibilities. And of course, each one of them could be positive or negative. So we're going to have to worry about finding the negatives. Now again, since this is a power of 3, I know that if I can find a single factor and divide it out, I'm going to be down to x squared. And x squared, I know how to factor. So I just need to find one of these that works. Now, if that were a power of 4, I'd need to find 2 of them that worked. So let's go ahead and try f of 1. That's 2 times 1 to the third minus 5 times 1 squared minus 6 times 1 plus 4. That's 2 minus 5 minus 6 plus 4. That comes out to be a -5. That is not a factor. Let's try -1. So it's 2 times -1 to the third minus 5 times -1 squared minus 6 times -1 plus 4. -1 to the third is -1, so times 2 is -2. -1 squared is +1 times -5 is -5. 6 times negative 6 times negative 1 is positive 6 plus 4. Well, that comes out to be a positive 3, so negative 1 does not work either. So we've eliminated 1. Now 1/2 is a definite possibility, but rather than plug a fraction into this, let's eliminate the other possibilities. So let's do f of 2 first. So that's 2 times 2 to the third power minus 5 times 2 squared minus 6 times 2 plus 4. I'll slow down for a second, let you catch up. Two to the third is 8 times 2 is 16 minus 2 squared is 4 times 5 is 20 minus 6 times 2 is 12 plus 4. That all adds up to, oops, hopefully a word here stays with me. There we go. What is that? Negative 4, negative 16 ends up to negative 12. So 2 is not a factor. Let's try negative 2. F of negative 2 equals 2 times negative 2 to the third minus 5 times negative 2 squared minus 6 times negative 2 plus 4. Well, negative 2 to the third is negative 8 times 2 is a negative 16. 2 squared is 4 times 5 is negative 5 is negative 20. Negative 6 times negative 2 is a positive 12 and plus 4. That ends up being negative 20. So 2 is not it at all either. So we're down to the 4 and the 1/2. Well, just because I'd rather not do the 1/2, let's try the 4. So f of 4 is 2 times 4 to the third minus 5 times 4 squared minus 6 times 4 plus 4. 4 to the third is 64 times 2 is 128. 4 squared is 16 times 5 is negative 5 is negative 80. Negative 6 times 4 is negative 24 and plus 4. That comes out to be a negative 20. So that is not it. Well, hopefully negative 4 works or we're in trouble here. We have to have 3 roots, and so far I've only got 3 possibilities left. So 2 times negative 4 to the third power minus 5 times 4 negative 4 squared minus 6 times negative 4 plus 4. Well, negative 4 to the third is negative 64 times 2 is a negative 128. Negative 4 squared is 16 times 5 is a negative 80. Positive 24 and plus 4. Well, that sure didn't work out either. That's nowhere near, that's way negative. So it looks like we're going to have to try 1/2. F of 1/2, 2 times 1/2 to the third minus 5 times 1/2 squared minus 6 times 1/2 plus 4. So I'm going to have to take this one the long way. 1/2 to the third is 1/8 times 2 is 1/4. 1/2 squared is 1/4 times negative 5 is negative 5/4. Negative 6 times 2 is a negative, or times 1/2 is negative 3 plus 4. that actually does add up to 0. So 1/2 is a factor. 1/2, I should say, is a root, which means x minus 1/2 is a factor. So that means we can divide this out. So I'm going to use that 1/2 in my synthetic division. I've got 2, -5, -6, and 4. So I bring down the 2. 2 times 1/2 is 1. -5 plus 1 is a -4. -4 plus 1/2 is a -2. -6 plus -2 is a -8. -8 plus 1/2 is 4. That gives us a remainder of 0, which we're expecting. So that means we have left here 2x squared minus 4x minus 8. So that, of course, is with that factor x minus 1/2. Now, at this point, I see, and I probably could have saw it before. Actually, no, I couldn't have before. These are all even coefficients, so I'm going to factor out a 2. I'm used to always putting my constant terms at the very beginning, so I move the 2 way up front here. But this is x squared minus 2x minus 4. If I try to factor that, I'm going to run into roadblocks. If I do my determinant, remember b squared minus 4ac, that's -2 squared minus 4 times 1 times -4. -2 squared is 4 minus 4 times 1 times -4 is a -16. That's 20. That's a positive number. So that tells me that these are real roots. They're not imaginary or complex. But that's not a perfect square either. For this to be factorable, that would have to be a perfect square. 20 is not. So what that's telling me is that there are 2 more roots here, but they are going to be radical. They're going to have square roots in them. Now, something that helps us with these roots to figure out how many of each type of root we should have is something called Descartes' rule of sign. And part of Descartes' rule of signs is if you have complex roots, they always come in pairs. So what that means is if you have, and they're conjugates. So if you have a root of 4i, that means you also have a root of -4i. If you have a root of 3 minus 2i, you also have a root of 3 plus 2i. They come in conjugate pairs. Also, part of Descartes' rule of signs is the number of positive roots. Is the number of sign changes in the coefficients of f of x. What do I mean by that? Well, let me give you an example. F of x equals 3x to the fourth minus 11x to the third minus x squared plus 19x plus 6. So the sign changes, we're talking about the coefficients. This is positive, positive 3. That's a negative 11. That's a negative 1, positive 19, positive 6. So the number of sign changes, we go from positive to negative, that's 1. Stays negative, there's no change. Negative to positive, that's 2. Stays positive. So that means that there are up to, at most, 2 positive roots. If there are not 2, then the number is decreased by an even amount. So what that means is that's saying that there's 2 or 0 in this case. The negative roots is the number of sign changes in f of negative x. What does that mean? What that means is you substitute negative x or negative 1x in for x into the function. So our function here I'm just going to rewrite the function quick. F of x equals that. F of negative x would equal 3 times negative x to the fourth minus 11 times negative x to the third minus negative x squared plus 19 times negative x plus 6. Negative x to the fourth is just a positive x, so that still stays 3x to the fourth. Negative x to the third is a negative x to the third, so negative times negative, that becomes a positive 11 x to the third. Negative x squared is just a positive x squared, so that's going to stay minus x squared. Negative x times 19 is a negative 19x, and then positive 6. So here we started out positive, that's still positive. We went to negative, so that's one sign change. Stayed negative, went back to positive, so that's a second sign change. So what that's telling us is that there are 2, again, or decreased by an even amount, or 0 negative roots. So what does that mean for us? Well, we go back to that rational root theorem. We've got all the values of p, all the factors of 3 or 3 or 1 or 3, which that would be for q. For p, for 6, it would be 1, 2, or 6. So when we go to test these out, we know our possibilities are 1 divided by 1, 1 divided by 3 is 1/3, 2 divided by 1 is 2, 2 divided by 3 is 2/3, 6 divided by 1 is 6, 6 divided by 3 is 2. We already have that one. Or, of course, the negatives of those. So if we're testing and we get 2 positive roots, once we find the second positive root, we can quit and move on and looking at the negative numbers. Now, I feel like I've exhausted that process of finding roots. And we would do f of 1, see if that equals 0, and go on, so on to find roots. But this helps us to figure out how many of each types of roots we should test. The last thing we want to talk today is linear factorization of polynomials. If I tell you the roots of a polynomial, you should be able to construct that polynomial. Sort of. If I have roots of 2, -3, and 2i. Well, first of all, if I have roots of 2i, those complex roots always come in pairs, so I must also have a root of -2i. My factors, remember these are the values for c in the factors. The factors come in the form of x minus c. So the root of +2 would give me a factor of x minus 2. The root of -3 gives me a factor of x plus 3. The root of 2i gives me a factor of x minus 2i. And the root of a -2i gives me a factor of x plus 2i. Now, a little trick, we're going to multiply these together to get part of the function. But as I'm multiplying, one thing I want to do is I want to make sure I multiply the two complex ones together first. Because the reason they come in pairs is so that they will cancel out. So let's do that. If we multiply those together, I'm going to trust you can do the FOIL. That's x squared plus 2ix minus 2ix. Now, -2i times +2i. Remember, -2 times +2 is -4. I times I is -1. So that's -4 times -1 is a +4. So the 2ix and -2ix cancel out. That multiplies to be x squared plus 4. I'll also multiply these. X times x is x squared. X times 3 is 3x. -2 times x is -2x. -2 times 3 is -6. So that makes, come on, x squared plus x minus 6. We go to multiply those out. X squared times x squared is x to the 4th. X squared times 4 is 4x squared. I'm actually going to do this. Plus 4x squared. X times x squared is x to the 3rd. X times 4 is 4x. -6 times x squared is -6x squared. -6 times 4 is -24. So now I have x to the 4th plus x to the 3rd. 4 and -6 make -2x squared plus 4x minus 24. That is the basis of our function. However, we're not totally done yet. We have our roots, 2, -3, 2i, and -2i. But we don't know, there might be some constant an that still multiplies that function. When we factored that out, that constant does not provide a root. So we have to know one more piece of information for this. And that would be, f of some value. Let's say I tell you that f of 1 equals negative 40. So what that means is we've got to put 1 in here for x, see what that value is. If it's not equal to negative 40, we'll find a to the n by dividing. So 1 to the 4th plus 1 to the 3rd minus 2 times 1 squared plus 4 times 1 minus 24. So 1 to the 4th is 1, 1 to the 3rd is 1, 1 squared is 1 times negative 2 is negative 2. 4 times 1 is 4, minus 24. If I add those up, right now I get negative 20. That's not negative 40, but I now know what an is because I take this value, negative 40, divided by what I got when I put 1 into the base part of the equation, the negative 20, gives me a 2, which means that an must be 2, which means I multiply this whole equation by 2. So it's 2x to the 4th plus 2x to the 3rd minus 4x squared plus 8x minus 48. That is my f of x. So again, the trick there is to evaluate this as though it is the whole function at whatever value is given. And take that amount you get and divide the value of the function at that point by the value you calculated, and that'll give you what that whole equation has to be multiplied by. Polynomial equations, polynomial functions are not simple. But so far we know a few things about polynomial functions. We know the end behavior. If it's an even function, in other words, it has an even power as its highest power, either both ends are up or both ends go down to negative infinity, depending on whether that first coefficient on that highest power of x is positive or negative. To be positive, that'd be negative. If it's odd, well, then the left end goes to negative infinity as the right end goes to positive infinity. That's if that first that an is positive, or if an is negative, it's the opposite. It comes down from negative infinity or positive infinity on the left side, goes down to negative infinity on the right side. We know the number of roots. We know the total roots is equal to n. Now, some might be repeated, but they're still total roots. We have that multiplicity of roots. Descartes' rule of signs tells us how many positive and how many negative ones to expect. Either that amount or reduced by an even number. And we know if x minus c is a factor, then f of c equals 0. Now, unfortunately, when it comes to polynomial functions, finding those roots, finding those x-intercepts or zeros, often comes down to just exhaustive calculation. Like we saw in that one example, it was the 7th number we tried. We tried x equals 1/2 before it finally gave us a root. And once we have those roots, even if it's only one, a lot of times it's easier to divide it out and get a function in a lower degree to keep working with, especially if it's a 3rd degree function, if x to the 3rd is the highest power, because then you get down to an x squared, which we know how to factor. At the very least, we didn't do it today, but you can take that x squared, that quadratic portion of the equation, and you can use the quadratic formula to find the last roots. And that's often what is necessary, especially if those last roots are irrational, they're radicals, or if they're complex, if there's imaginary numbers within them. So let's find all the roots for f of x equals x to the 3rd plus 12x squared plus 21x plus 10. First of all, how many positive roots? Well, this coefficient is positive, 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 positive. There are no positive roots here. There are no sign changes. F of negative x, this would be negative x to the 3rd plus 12 times negative x squared plus 21 times negative x plus 10. So this is negative x to the 3rd is a negative x to the 3rd. Negative x squared is just positive x squared, so that's still 12x squared. 21 times negative x is negative 21x plus 10. So this is negative, positive, negative, positive. There's 1, 2, 3 changes. So negative roots there's 3 or 1. Now that's very significant because that's telling us there's at least one real root here. It's going to be a negative number, but there's at least one of them. Possible roots. Well, this is a 1, so Q is just a 1, is the only possible value. That's a 10, so P can be 1, 2, 5, or 10. So possible roots are, there's no positive, so we're not going to worry about the positive. Negative 1, negative 2, negative 5, or negative 10. Let's try them. Now we've only got like 3 minutes left, so I'm going to try these rather quickly. F of negative 1 is going to be negative 1 to the 3rd plus 12 times negative 1 squared plus 21 times negative 1 plus 10. This is negative 1 plus 12 minus 21 plus 10. That does equal 0. So negative 1 is a root. That gives us a factor of x plus 1. So what I'm going to do is I'm going to divide that out. I have 1, 12, 21, and 10. Let's divide it out and see what we got. So I bring down the 1. 1 times 1 is 1. 12 plus 1 is 13. 13 times 1 is 13. 21 plus 13 is 34. 34 times 1, something didn't work there. Oh, it's a negative 1 is what I got to put in there. Sorry. I forgot to convert it back. C is negative 1, not positive 1. So that's a negative 1. I still bring down the 1. 1 times negative 1 is negative 1. 12 plus negative 1 is 11. 11 times negative 1 is negative 11. 21 plus negative 11 is 10. 10 times negative 1 is negative 10, so that's a 0. That's what we needed, that 0 remainder. But this is giving us x squared plus 11x plus 10. We can factor that. That factors into x plus 1, x plus 10, which tells us our other factors are negative 1 and negative 10. And we already had negative 1 as a factor. So negative 1 is repeated in this. Remember, that's telling us that at that point, it's going to touch the graph or touch the axis and turn back around from either from the bottom or from the top, one of the two. Chances are that one's going to be coming from the top. Okay, so that was a lot to absorb for one day. You do have homework from last class, homework 4A, which is going to be due tomorrow. Homework 4B, which is for today, which will be due Thursday. And of course, coming up, once you get both of those homeworks done, quiz 4 is based on both of those homeworks, which will be due Friday. So coming up on Wednesday, it'll be our first lecture of week 5. That'll be our only lecture of week 5. Because remember, the second class, we're on kind of a weird week because the week starts on a Wednesday for us right now. Next Tuesday, next Monday, 1 week from today. So that'll be Monday, what is that, 7th? Yes, October 7th is test 1. So be prepared for that. Also note that in my math lab, there's a test 1 review that will help you review, but it's also up to 20 points extra credit. So if you complete that before next Monday, that's worth up to 20 points extra credit for you. Anybody have any questions? Okay, I'm actually 40 seconds past my time, so sorry about that. You guys have a great day, and we will see you on Wednesday. You're welcome.